In this video I wanted to show how you can use the point direction form of a line to not describe the whole line, but only a line segment out of it, right? So let's look at this example here. We are looking at the triangle ABC and assume you want to describe the side AB of this triangle. Yeah. Now, what we can do is we can think of a line that goes through the point AB. Let's move this up a little bit so that's nicely through the points AB. So this line, we call it G, goes through the point AB. And now we can describe it with the point direction form. So G is x, y, z is equal to a position vector. Let's use this one. So OA plus t times the direction vector, and as a direction vector we just use this one here, which is the vector AB. Right? Now this here describes the whole line. It's the point direction form of this line G, and we get all the points on this line by plugging in values for t. So t can be any value we want. Now if we restrict t, we can actually restrict it in a way that it only gives us value on this line segment here. So my question to you, think for a second, how do we have to restrict t so that the values that we get here all refer to points on this line segment here? So the solution is actually surprisingly simple. You just have to think where you end up when you plug in some values for t. So for instance, if you plug in the value 0 for t, where do you end up? Well, you end up here, right? So for t equals 0, you end up at the point A. So you get the position vector of the point A, right? So you would end up here. If you plug in, let's say 1 for t, then you end up OA plus 1AB, so you end up here. You end up at OA plus 1AB, which is equal to the vector or position vector OB. Okay, now for t1/2, we can clearly see that we would end up just here in the middle, right? And now probably you're already guessing that if t is between 0 and 1, we will end up on all these points here between A and B. Right? If t is greater than 1, so if it's for instance 2, then we would end up somewhere over here. If it's less than 0, then we would end up here to the left of A. But if we restrict t and we say it's just between 0 and 1, then we get all these points between A and B. So the solution is we need to restrict t to be t element of in the interval 0, 1, and this then describes our line segment. Doesn't describe the whole line anymore, but with this description it really describes this line segment here.